Questions will be addressed at the end of today's session. We will be asking you a polling question throughout today's session as well, a couple of polling questions. And now I'd like to turn the webinar over to Tom to kick off today's presentation.
All right. Good morning, good afternoon, everybody. This is Tom Van Dalen. If you haven't done so yet, we would really like to hear answers to the question that's on your screen right now. We would like to know what frustrates the scientists that you work with, or yourself if you're a scientist, the most about the analysis of visualization tools that you are using. So please use the chat window to give us your answers, and we'll talk about that later in the presentation. Okay, so today I'm here with Richard Heath from Amplified Informatics, and we're going to talk about a new approach to collaborative scientific analysis with a tool called pipette analysis. So the outline for today, we're going to give an introduction to the types of problems that pipette analysis addresses and why this is such a unique tool. Then Richard will give an overview demonstration of the tool, all the different aspects of the application and how you can use that to analyze data, get a better understanding of your data. And then I'll take over and I'll talk about a number of use cases. I'll talk about pipette analysis as it is applied to a virtual screening data set. I'll talk about an application around assay data analysis. And then I'll talk about how, as a scientific developer, how I can build new services to be deployed in pipette analysis. I'm going to show you how that's done. Then we'll wrap up. We'll have plenty of time for Q&A. We'll plan to run for about 30, 35 minutes, and then we want to make sure that we get all your questions answered. So with that, a real quick introduction. And I'm going to ask a second question to the audience. And the question is, how many years have you been using Python Pilot? I know there's a diverse set of people on the line. Some people might have never used Python Pilot, so that's an answer 0. Some others might be relatively new. And I know there are some people on the line that have used Python Pilot for many, many years. So we really like to understand the distribution there among the audience. So if you can answer that question, I will talk about the results in just a couple of seconds. Okay, I think we have our answers in. So I'm going to close the poll, and I'm going to share the results here. So we have a fair number of new users, people that are new to Python Pilot, which is really cool. We have a number of people that have been using it for a couple of years, and then we have a number of people that have been using it for a long time. So we have a pretty distribution here. So what I'll do next then is give a very brief introduction to what Python Pilot is, for those of you that are new to it. So Python Pilot is a tool to build, some people workflows, we call them data pipelines. And data pipelines are sets of components that can process data. They can read data from different places, they can apply different operations to data, and they can put data into a particular place. They can put it back into a database, they can create a report, and what have you. Python Pilot has been around for quite a while. It's used in many different areas. It's very popular in the sort of chemistry domain, the biology domain, but it really introduced a very flexible way of processing your data, wherever that data might be, whatever shape that data is in. The reason I'm talking about Python Pilot here is that, as Richard will talk about in a second, is that Pipette is a tool that is very complementary to Python Pilot. It's based on Python Pilot, and we extended it with Python Pilot. And for those of you with some experience with Python Pilot, will, I think, very quickly appreciate the kinds of things that pipette analysis can do. So that's for a real quick introduction to Pipeline Pilot. And with that, I'll hand it over to Richard, who is going to give an introduction to pipette analysis.
Thanks, Tom. Hi, everybody. My name is Richard Heath with Amplified Informatics. Many of you may know me already. I've been an enthusiastic Pipeline Pilot user for many, many years. And over my career, I've got to work on all sorts of cool scientific problems. And with many of those, I've applied tools like Pipeline Pilot, like Spotfire, and other analysis and visualization tools. And I've been impressed by the breadth of scientific questions I've been able to answer with those tools, and also with the speed in which I've been able to answer those questions. I think once you start using data pipelining tools and visualization tools, you realize the value. And it'd be great if we could extend those tools to every scientist within our organizations. However, that brings challenges. These are typically expert tools, and there's a steep learning curve that's associated with them. So one of the things we wanted to do with pipette analysis was give every scientist the ability to have access to these tools, get broader access to data using them, be able to analyze their data in a very consistent, repeatable way, and get a broader understanding. And through that, we feel that the quality of science and the speed in which they can do science will also benefit in the same way that we've seen those benefits by using those expert tools. That does bring some challenges with it, though. So the first thing we realized we had to do with pipette analysis was make it very easy for the average scientist to pick up and use. I think we're all used to installing applications on our smartphones or on our tablets, and we don't go on a week-long training course before we can use them. We're just used to being able to pick them up and use them. And that's certainly not the case with many of these traditional expert tools. So from the start, we designed with a scientist who doesn't use this tool on a day-to-day basis. Maybe they use it once a week. Maybe they use it intensively every few months. But we wanted them to be able to come to the tool and use it without having a really steep learning curve. The other thing the tool needs to do is help guide people down the paths of things they've done previously, and we'll see that shortly. The other thing that's changed in the last few years is the breadth of devices that are in our environments. So a few years ago, it was mainly desktop PCs or laptops. Now, iPads are commonplace. We start seeing Microsoft Surface Pros. Laptops have touch screens. And we're also seeing technologies like interactive whiteboards cross across from the education environments, where they're very prevalent, into research. And so we knew we had to support this diverse range of devices, and there had to be a consistent user interface between them. The user shouldn't have to learn a different application on a different device, and it should just be available through a web application. We don't want to go through all the packaging and deployment headaches that applications that we have to install incur. The next thing we wanted to bring over these expert tools was the ability to encourage collaborative analysis. So a lab scientist can immediately take advantage of some of the analysis pipelines that the computational scientists maybe in the organization have developed before. They should be able to just take that data analysis pipeline, put their data into it, and tweak it to get what they need out of it. Equally, they should be able to take some of the services that the scientific developers in your organization have written using Pipeline Pilot and take advantage of those immediately, whether they look at project data, whether they go out and search external databases, whether they calculate interesting properties, or whether they generate useful reports. We knew the tool had to integrate seamlessly into your environment. It couldn't sit there as a big monolithic application. So it needed to be launchable from lots of different locations. You might want to embed the charting in the application that you're writing in-house, potentially. And when the data goes between the pipelining and the charting shouldn't be the endpoint, as it is with some technologies. You should be able to select and filter data and send it on to other applications. And finally, as I mentioned earlier, I've been an enthusiastic Pipeline Pilot user for many years. I think it's the best data pipelining platform that's out there. And so we wanted it to work with Pipeline Pilot, but even more than that, we wanted to be able to install it on an existing Pipeline Pilot server, that many of you have already, without having to go to the trouble of installing extra servers, setting up Oracle databases. It's a simple 2-minute install on top of an existing Pipeline Pilot server, and you can start taking advantage of the tool. And you can take advantage of all the Pipeline Pilot services, whether they be protocols or components that you've developed already in your organization. It's very easy to take those and start to expose them through pipette analysis, as we'll see today. So with that, I'm going to dive into the demo, but before I do so, I'm just going to dive back to Tom and ask him to summarize the poll question that we had at the start.
All right, thank you, Richard. We got a number of interesting answers, and I tried to sort of group them by theme. So one common theme seems to be that tools that people are using today are not easy to use. There's a learning curve, there's training required to use them effectively. Also, the other thing that we picked up on is that tools don't seem to understand scientific data in a lot of cases, that there are generic tools out there that work with all kinds of data, but not specifically designed to deal with the kinds of data that we need to deal with in our community. And the third theme was more around integration. There are really good tools out there, but they're not necessarily integrated with the other tools that you might be using as a scientist. Not integrated with database tools, not always integrated well with the tool like Pipeline Pilot, so you might be using Spotfire, but going back and forth with the other tools is a challenge. So integration, I think, is a third theme that came out of the poll that we did.
Good. I'll try and touch on those as I go through the demo then. And I think they tie into some of the things that I said in the introduction there, so that's good to hear that people on the phone have felt the same pain as people we've been talking to previously. So with that, I'll dive over to the application itself. I know many people on the phone have probably watched the video on YouTube already that gives kind of the 5-minute overview. So while I'm going to give people an overview of the application, I am going to touch on some different topics as I go through. So even if you've seen that video, hopefully this will still be interesting. So when you first come into the pipelining part of pipette analysis, you're going to see a screen similar to this. And the first thing that users are encouraged to do is hit this big Add a Service button at the top of the screen. When they do that, they're going to see a list of services. These are all Pipeline Pilot protocols behind the scenes for those of you that know Pipeline Pilot. And the first thing we want to do is get some data from somewhere. And you'll notice right at the top of the list there is Get Project Compounds. This is something I've done a few times, obviously, in setting up this demo today. And so the system's remembered that and moved those items that I'm using to the top of the list. And this comes back to what we were saying before in terms of infrequent users. We're helping them guide them down something they maybe did a couple of weeks ago. They can immediately find those things. Obviously, there's a search box there that searches the names and the summaries with keywords for each of these services. So everyone's very proficient at crafting Google search terms nowadays. So if it is something unusual they want to do, hopefully they can run a search and be able to find it. So I'll select that service, and that service can throw up a nice little dialog where I can pick the project I want to retrieve data for and run it. And so you can see immediately I've retrieved 247 compounds for my project. Some expert developers come along, previously written this service, and I've not had to craft a complex search and understand the underlying data model of some database to get access to that data. I've just been able to run a really simple service that gives me what I want. Now I've got that data, I can page through it and view each of those compounds. By clicking on them, I can view a larger view of that. And if I've retrieved other types of scientific data, maybe it's imaging-related data, I'd see thumbnails of the images there, and if there were multiple layers in the images, I'd be able to flick through them. And that ties back to what people on the phone were saying earlier through the poll, that having built-in capability around scientific data is key. We have some unique needs as scientists, and a lot of the general tools don't provide that. Seeing your compounds or your images wherever you go is really valuable. And we'll see that as we move over onto the visualization side shortly as well. So now I've got some data, I can continue building my data pipeline down the screen. So I can add a Lipinski filter and start to see some properties get calculated. If I want, I can start sorting on particular properties. And as you can see, it's very easy for a scientist to start working with their data, build these analysis pipelines down the screen, pick from the selection of services they have available, and see their data at every step, so they've got an understanding of how they're manipulating it. This is one of the differences between the expert tool, like the Pipeline Pilot Professional client that many of you are familiar with, and the scientist tool, where the experts think more about the process, the scientists think more about the data. And so we move the data to the forefront. At any time, I can take data I have in this data pipeline and drag it to the left-hand side here to save it. Give it a name. And that data is now available in my data sandbox on the left-hand side whenever I need it. If I log into a different device, it will also be there as well. So if I pull it up on my iPad, I can drag any of the data from the pipeline or from the My Data section across to the right-hand side to some of the outputs. And so you'll see that now this will generate a Pipeline Pilot report showing a summary of all those compounds I've got. So everything on the right-hand side is integration to other applications or reports that are being generated from Pipeline Pilot or other tools. And again, this comes back to what we heard earlier in the poll question, where it's desirable for this tool to be very tightly tied into the other things that you have already. At the bottom of the screen here, you can see I've got a Save Pipeline button. So if this was an analysis I did on a frequent basis, I can come along and I can save it, give it a name, and then in future, when I come along, if I clear the pipeline and pick again, you'll see I have this new templated set of services available called Richard's Project Data. And when I run that, it will bring back that data analysis pipeline and all the settings I've got. If I was a power user, I could share that with my organization. So, for example, the computational chemists that do have interesting pipelining workflows, they can share them, and scientists can immediately take advantage of those as they could take advantage of individual services. Often we get data files like an SD file. Maybe we've exported it through some web-based tool where we've run some interesting search for some reagents, or maybe we've just been emailed it from a collaborator. It's really easy to bring common scientific data files in. We just drag them across and drop them into the application, and they'll get uploaded into the My Data section. And again, we can just drag those across as a starting point for the data pipeline, and we can add services as we want from there. So there you can see the Lipinski filter has passed 6,300 of those 7,500 compounds that we imported. The final thing I want to show before we switch over to visualization is kind of the developer role we talked about. Many of you probably are authoring Pipeline Pilot protocols and components. So I'm just going to switch users. And I'm going to bring in some data into the pipeline. You'll notice as a developer I see a couple of extra blue icons. The user I just logged in as has an extra permission that's been set for them in Pipeline Pilot. And they get these extra icons. If I click on the Lipinski filter service icon, you'll see it launches the Pipeline Pilot Professional client that many of you are familiar with. If you are a new Pipeline Pilot user, this is the common authoring tool that's been in use for probably at least 10 years now for Pipeline Pilot. You can see, again, those of you who are familiar with Pipeline Pilot, this is a really standard protocol. It's just a simple set of components. The help in here gets brought across into pipette analysis. Any parameters that would have been defined for this service would have also been displayed in that nice little dialog that we saw, for example, for the Get Project Data service. So it's really straightforward pipeline pilot behind the scenes. There's no magic here. You just take the existing services you have and the components that you have and just expose them through pipette analysis, pipeline, and client. So let me switch back to my other user. So let's move across into the visualization client now and see how easy it is for scientists to start visualizing and filtering and selecting parts of their data. So I'm going to take these 6,500 compounds, send them across to visualize. Oops. So if the user came in for the first time, the screen would look something like this. As well. So you can see all the properties on the data that I brought in down the left-hand side here with a little indication of what their type is. To start with, I see a set of interconnected histograms, and I can come along and make selections on these and see it reflected on the other histograms. I can also switch to a tabular view of the data if that's preferable. But once I'm convinced I've brought the right data in, I can then start to develop visualizations that are of interest to me. So the first thing I'm going to do is bring down A log P onto my x-axis. I'm going to bring molecular weight down onto my y-axis. And I see a range of chart types that are suitable for viewing this data. So you can see here I've started out with a scatter plot. Again, it's all selectable. And I can preview individual points here. And as you can see, we show all the data, including structure. And this comes back to the fact that with scientific data, it's a little bit different to these general tools. We want our science to be there all the time. Being able to see what the structure is really is critical to understand what's going on here and why this is an outlier. We can simply change things like switch to a log scale by clicking on the axes we wish to change, and we can switch to different chart types by selecting them here. Another example of one of the areas in which we're kind of specific to science is a lot of the visualizations we have and the visualizations we want to develop in the future with collaboration with customers do have a scientific focus. And one of the things that we were asked for was the ability to see a heat map such as this when you have large amounts of compounds, tens of thousands of compounds, but equally to be able to understand individual outliers. So we have this hybrid chart where we show the heat map, but you can still get into these individual outliers and preview what the compounds are and understand what's going on. And again, it's all selectable. And when I select data on the chart, I can come down here and send it onto all the other tools that I've got linked in. So I can send it back to the pipelining application, for example, and start working with that selection. I can send it to any of the reports I have here on the side directly from the visualization application. We can control the look of these charts through additional configurations. So, for example, I can put on another property here to control the radius. I can maybe use a categorical property to color these points. And I can easily switch between different chart types. So I can trellis these based on the categorical property I've just used. Or I can even switch to a 3D plot that lets me explore additional dimensions. And again, everything's still previewable. We can still see our compounds and what's going on. It's very easy to convert these into dashboards. So I can quickly come along and start adding other spaces for charts here. Maybe I'm going to put a histogram for A log P there. And maybe at the bottom here, I want to see the name and the CAS number. And as I make selections on these charts, they'll be immediately reflected across all the other charts I have in the data set. So again, the data is very connected together. There's a lot I've not shown here. We can filter these things down. There's a lot of charts. Hopefully, this gives you a sense of how easy it is for someone to come along as a non-expert user and start to interact with their data and really understand what's going on. So with that, I'll switch back to Tom.
All right, thank you, Richard. So while I make myself presenter, let's go into some realistic use cases. And the first one I want to talk about is around virtual screening. And just to introduce the topic, some of you might be new to it or might not be, or might be working in a different domain. Virtual screening is about searching libraries of molecules. They could be vendor libraries or corporate libraries to identify a subset of structures that is most likely to be active, to bind to a target that you can then synthesize approaches and test. You can save yourself a lot of time if you do this on a computer. There's different computational methods that are being used for that. People use docking algorithms to computationally assess how well a compound binds to a particular target. Ligand-based methods where you can do what's called pharmacophore analyses. You can compute a lot of properties for compounds, physicochemical properties. And lastly, and this is a very interesting one, you can apply statistical models. They can give you some kind of a prediction how active a particular compound might be against a given target. And these models are based on known data, experimental data for other compounds that you have tested. Now, what are the challenges here? You have to make that selection. You start with thousands, potentially hundreds of thousands of compounds, and you need to select for desirable properties. You might want to find compounds that are similar to compounds that you know to be active. And typically it's about identifying those compounds that are not only active, but they're also selective and are safe. And if you can reduce your set of your data set from hundreds of thousands of compounds to a much smaller set, say 100 or a couple of hundred, those are compounds you can take in the lab and actually test. So with that introduction, let's go back to pipette and let's indicate how this might work. And I'm going to start from a very common data set. It's a vendor library. This is Maybridge, and we ship that with Python Pilot. That is my starting point. So I'm going to get a preview of the data. This is the information that's in this data file. And I'm now going to compute some properties. I'm going to add data to this data set, and then going to analyze it in the visualization, in the charting section of pipette. So the first thing I'll do is I'm going to add a service that I actually created with Python Pilot the other day, and it's a service to create statistical models. It's called multiple models. That's the name I added, and it will create a set of I think 13 statistical models that will give you a prediction for activity in different classes of therapeutics. So you get these numbers for, let's say, antipsychotic, could be a calcium channel blocker, and so on. So these are indications that these might be active or might not be active in that particular domain. Some other things I will add here to load more data in the system is just to compute some properties, some typical physicochemical properties, and add that to the data set. And if you look at the properties, we've computed acceptors, donors, ALP, and things like that. And the last thing, let's see how these cluster together. So I'm going to add a service, again, based on the Python Pilot protocol, that will do clustering. And when I add that, it will add a cluster number to each of these compounds. So this is the first compound is in cluster 1, and you can step through that and see how they all cluster. So this could be the starting point now for you to graphically inspect your data set and try to get a better understanding of these compounds and which compounds might be valuable in taking forward. So I'm going to take the data and I'm going to put it into the visualizer, and it's going to show me the properties on the left-hand side that are part of that data set, and I can do the same kinds of things as what Richard has been showing. I can take the data and look at it in many different ways. So the default window you get is something like this, and it gives you immediately an indication of the profiles, the property profiles for these compounds. You know, what's the distribution for ALP, molecular weight, and so on. But also, you know, what kind of ranges of activity can we expect for these types of compounds. So let's create a simple graph here where we're just looking at two very common properties. So let's look at ALP and let's look at molecular weight. Now we'll see what the distribution is. Richard showed you how you can take, look at outliers and so on. But what I want to do here is set some limits on the kinds of compounds that I'm after. So in this case, I'm after a compound with a higher value of ALP, and I'm after compounds that have a specific molecular weight range. So I don't want compounds that are too heavy, and I want compounds, let's say, between about 250 and 500. So that's an initial set of limits that I set on the compounds. And a third thing that I'll do now here is I'm going to see how they cluster. So I'm going to use the cluster number, and I'm going to use that as a way to separate the data. And when you look here, you see that it clusters in these 10 different clusters. Some clusters with a lot of compounds, some are very small. That's what you typically see. And what I'll put on the side is a histogram of those clusters. And let's make it a little bit bigger. This is quite interesting. So now I can see, for the different clusters, how they are distributed, and actually the kind of view I wanted to show you is how this corresponds to compounds. So let's look at the compounds here on the right-hand side. There you go. So for the different clusters, I can now get to see what they look like. So in this case, this is one class of compounds. I can make another selection here to get another set of compounds, etc. So I can very quickly visually inspect and see what my data looks like, and try to see what the kinds of compounds are that I'm after to take further in my eventually into the lab. So that's one way to analyze the data. Now remember, I used to add the statistical information in the data as well. So the second thing I want to do now is look at how the activity is grouped within this data set. So I'm going to look at the different activity models, and let's say the one I'm particularly interested in is the likelihood that this would be an ACE inhibitor compared to other classes. And this is a way to get into, let's say, selectivity. So ACE inhibitor, antimicrobial, and antipsychotic, can I find compounds that are likely to be one and not the other? So that gets it into selectivity. So let's again put some compounds on the side here, and let's then see what we can learn from this. So in this case, we'll find, let's see, ACE inhibitors that are compounds that have high values for ACE inhibitors on this side, low values for ACE inhibitors on this side. And let's see if we can find compounds that are high for ACE inhibitors and low for antimicrobial. So that will be this quadrant, and that will then be updated in the table on the right-hand side, and we can see how that distributes in the other plots. So there's a lot more work that you might want to do at this point just to get to know your data better, but this is just an indication of the kinds of manipulations and the kinds of charting that you might do to, in an ad hoc way, try to better understand your data. So there's one example. The other example is around assay data analysis. And just to introduce that topic, assay data, massive amounts of assay data are generated from high throughput screens. They produce data regarding potential activity of drug candidates. Different types of assays, in vitro, in vivo, and assay types assays, they all generate data, and there's a number of challenges that come with that data. One, it's common that there are errors within your data set. You might have outliers in your data. You might have wells that are not really, that haven't reacted. There might be problems with the measurements, and those are errors that you need to detect quickly. Eventually, what you need to do is to identify the most promising compounds. What are the hits within my assay? Can I take those forward? There might be promiscuous hitters. That is, those are compounds that hit, but not for the right reasons, and those show up in many assays, and those you need to filter out. And find compounds that are active in multiple assays. Okay, those could be particularly interesting. How can I combine data from different assays? So let's go back to pipette and let's try that. So what I'll start with is data from a project, and I've done this before, so as Ricky showed you before, this shows up at the top. So I'm going to take data from a project that is called Project 27. I get different types of data. I'm getting the assay data later, so this will give me an initial set of batches. The next thing I will do is actually get the assay data that I will join in from a different database. So I'm going to do a lookup of the biology and merge that with this data. There you go. So I have my biology data, and there's one other type of information that I will link in here, and that will be sample data that I'm getting from a different database. So I'm combining this data from different sources, and let's say what I want to do next is I want to, again, see how they cluster. And I want to apply a filter, because there are some data points that don't relate to the actual well. They deal with information about the specific model. So I'm going to add a filter here. I'm going to say any data records that contain PL, the string PL, those are the ones that I want to keep. And that reduces it from 266 to 250 data items. So at this point, let's put it in the visualizer. Let's see. Let's now plot this. And the type of plot I want to create is more a plate-based visualization. So what I'm going to do is I'm going to take the column number, and I'm going to take the row number, and I'm going to pick a property that I want to. I'm sorry, I need to do one more thing. I need to take the container ID that is going to tell me how the data is laid out. So I get a plate map now that I can look at in different ways. And you can see which wells have numbers, which wells don't have numbers. And then the last thing I'll do is I'm going to look at a particular property that I want to inspect. So this will be data from a cytotoxicity screen. It's going to tell me where the actives are, to tell me where the inactives are. I can fly over to inspect some of these compounds, and actives, inactives, and so on. In a very similar fashion, I can take other kinds of data. So this would be an HAT screen, and look at the same information. So this looks like, in this case, it's very few actives. There's a couple here. Mostly these are inactive compounds. So let's do one other thing here. Let's see how they cluster. And I'm going to take the cluster information on the right-hand side, and now I can then see how they cluster together. So if I select a particular cluster, I find out that those are primarily located on this plate, and so on, and I can add or select different clusters just to learn more about my data. And then if I combine that with some compounds at the bottom, it gives me a quite complete picture of everything that's going on my plate. So I need to property batch number here, which is the compound identifier, to look at the compounds. So I'm going to stop it there for the assay data demo. I hope you get an idea of the kinds of analyses that you would do with this kinds of data. So just to wrap it up for today, what I'll do then is to show you what it takes to create a new service for pipette. You saw me use a couple of services. One was the clustering that I customized. The other one were the services to get data from particular databases. Creating a service is quite straightforward, and I'll show you how that's done. So within Python Pilot, what I'll do is I'll say new protocol from templates. And this brings me to a location where I find templates for different kinds of services that I might want to build. So for pipette analysis, right now there's 3 kinds of services. I can build a reader service to get data into pipette. I can build an output service to allow people to create reports, which will show you a PDF service and HTML service that you can drag data into. The service I want to show here is how you create a new calculator. The template is very simple, but it does show you that a calculator service has an input port and an output port, and that's what you need to provide. So what I can do then is I can, let's say you want to make this a calculator for a set of ADME properties. So I'm going to get some ADME calculators. Let's say we take this one and blood-brain barrier, and we'll take intestinal absorption, and we'll take this out of the template. And at this point, I have a valid pipette service. The last thing I need to do then is I need to save this in a location there where pipette can find it. And this goes into the folder called analysis. There's a folder called services, and I can call these ADME. Let's call it test, and I save it there. So at this point, that service is created. I can now go back to pipette. Let's clear this up. Let's put some data in here, and I can now go to add service, and I'll find the service that I just created. And if I click on the service, it will add that as the next step in the pipeline. And those are really all the steps that you need to go through to build a calculator. They can get a lot more complicated. You can use any type of component that you know from Python Pilot. You can do clustering, you can do statistical analysis. We've applied this to other areas like imaging, and those are all easy extensions that you can apply to pipette. And those are key extensions because out of the box, it will probably not do all the things that you need it to do. So this kind of customization is really key to the I think to the success of a tool like pipette. So with that, we're running out of time. Let me go back to the slides and we will wrap it up. So one comment that I want to make is that Pipette is an on-prem tool, can be used in your existing Pipeline Pilot installation. It's also a tool that is completely integrated with Science Cloud. And we've talked about Science Cloud in different on different occasions, but Science Cloud is all about working together on a project with your partners that in most cases are external, and working with data, analyzing data, trying to understand the data better, and we found it absolutely critical that it was a flexible visualization tool available, an analysis tool that everybody involved in a project can use. It's also critical, that these tools are mobile, that people from anywhere at any time can access these applications. So that's why Pipette was chosen as the visualization tool that's integrated with Science Cloud. So just to summarize, what we have shown you today, hopefully, and hopefully you agree with that, Pipette Analysis is a tool that's easy to pick up, easy to use. It encourages collaborative analysis, doing analysis with your partners, with people that work in the same project, and communicating that. It supports the devices that your scientists use. That might sometimes be an iPad, that might be a desktop, that might be many different types of machines. And it integrates into your environment. So it needs to talk to your databases, talk to your other analysis tools, talk to your registration tools, and so on. It works with your existing Pipeline Pilot server, and it uses your existing Pipeline Pilot services. Now, having said all that, we are just getting started. A first release in Science Cloud was a couple of months ago. An on-prem release is just around the corner. We'd like to hear from you where you want us to take this next. And there's many more things that we can do, many more chart types that we can add. We really like to have a conversation with you to understand what the tool does well, where it's falling short, and the kinds of analyses that you need to do with Pipette. So one last thing then, we have a couple of webinars coming up. Tomorrow we're talking about mobile, running Pipeline Pilot on a mobile device. We have a webinar on the chemistry SDK, deploying Pipeline Pilot in HPC environments. So lots of Pipeline Pilot related webinars coming up. And then we can find it at various trade shows and seminars in London, Frankfurt. And we are planning a set of local Pipeline Pilot user group meetings, and you will hear more about that soon. So with that, if you have any more questions, please contact your Biovia salesperson or send me an email. Use my email address for a personal demo, and we're more than happy to give you to see how Pipette can be applied to your challenges.
Okay, thanks, Ton. Well, we're going to go ahead and move to the Q&A now. We have a question that has come in. Is filtering possible inside the visualization for things like slider bars, etc.?
Yep, so visualization is possible. I think Tom touched on that briefly. So you can filter down numeric properties to get access to them. And there are some actual improvements coming in the next few weeks around that as well. But yes, that's definitely possible.
Okay, and then